New sustainable technology, Sun with Face, the perovskite solar revolution, a tale of technological triumph. Imagine a world where solar energy isn't just a technology, but a breathtaking revolution that transforms how we interact with power. This is the story of perovskite solar cells, the underdog technology that's about to turn the energy world upside down. Our journey begins in the labs of Oxford PV, where a team of brilliant scientists looks less like stereotypical researchers and more like energy superheroes. They've cracked a code that traditional silicon solar panels thought was impossible. While old-school solar panels were busy being rigid, expensive, and somewhat boring, perovskite cells burst onto the scene like a rock star disrupting a classical music concert. Picture Sarah, our visionary young engineer from the future, standing in 2035, her house literally glowing with paper-thin, iridescent solar panels that look like they've been designed by a futuristic fashion artist. These aren't just solar panels, they're magical membranes transforming entire cityscapes into living, breathing solar ecosystems. The global hunt for the perfect solar solution has been nothing short of an international spy movie. In Poland, Sale Technologies is pioneering flexible solar panels that can wrap around buildings like a superhero's skin. Meanwhile, in the Swiss laboratories of EPFL, researchers are developing stability solutions that make previous solar technologies look like temperamental teenagers. The Chinese tech giant Trina Solar isn't just watching from the sidelines. They're diving headfirst into perovskite research, developing commercial-scale production techniques that could make solar panels cheaper than your monthly coffee budget. Imagine that, renewable energy becoming more accessible than your caffeine addiction. Toyota's research labs in Japan are taking an even wilder approach. They're not just thinking about solar panels, they're dreaming about integrating these magical cells into electric vehicles. A car that charges itself while looking drop-dead gorgeous? Yes, please. The numbers tell a story of potential unprecedented transformation. Currently, these miraculous cells are achieving conversion rates over 25%, dancing toe-to-toe with traditional silicon cells but at a fraction of the production cost. By 2030, experts predict efficiency could jump to an astonishing 35 to 40%, with production costs plummeting from 30 cents to 0.50 per watt to a mind-blowing 10 cents to 0.20 per watt. But here's the real kicker: by 2040, perovskite cells might be everywhere. Window glass, solar-powered car surfaces, generating electricity. That trendy jacket you're wearing, it might just be powering your smartphone while keeping you stylish. The technology could reduce solar panel costs by up to 75%, making renewable energy as common as smartphones. From the cold research labs of Norway's NTNU developing technologies for extreme environments, to the innovative thin-film designs of China's Microquanta Semiconductor, this isn't just a technological evolution. It's a global revolution, a collective reimagining of how we generate and consume energy. The competitive landscape isn't just about who can create the most efficient solar cell. It's about who can dream the biggest, who can see a future where every surface is a potential power generator, where clean energy isn't a luxury, but a fundamental right. As Bill Gates-backed Breakthrough Energy Ventures continues to invest millions, as researchers in Switzerland, Poland, Germany, and beyond push the boundaries of what's possible, one thing becomes crystal clear: the future of energy is not just bright, it's brilliantly, wonderfully perovskite. Speedy, direct air carbon capture, Earth's ultimate vacuum cleaner. Imagine a planet with a runny nose, and humanity has finally invented the ultimate tissue: direct air carbon capture. This isn't just another environmental technology, it's Earth's very own superhero vacuum cleaner, sucking carbon dioxide right out of the atmosphere like a cosmic cleaning service. Meet the planetary problem solvers, a quirky band of engineers and scientists who looked at our climate crisis and decided to fight back with massive fans, chemical wizardry, and an audacious vision of turning carbon from environmental villain to economic opportunity. At the forefront of this atmospheric rescue mission are pioneers like Klaus, the Swiss engineer whose carbon capture facility in Iceland looks like it escaped from a science fiction movie set. The magic happens through a deceptively simple process. Massive fans draw ambient air into complex filtration systems, where specialized chemical solutions perform molecular gymnastics, binding with CO2 molecules and extracting them from the atmosphere. It's like a high-tech kidnapping operation, but instead of ransoming carbon, these companies are transforming it into something useful. Companies like Climeworks are leading the charge, with their Orca facility in Iceland capable of removing 4,000 tons of carbon dioxide annually. Picture giant air conditioners sitting in a lunar-like landscape, methodically sucking carbon from the sky. It's part science, part environmental performance art. Carbon engineering in Canada has driven down capture costs to between $94 to $232 per ton, a price that continues to plummet as technology advances. The real excitement lies in the potential transformations. Captured carbon isn't just being stored, it's being reborn as synthetic fuels, construction materials, plastic alternatives, and even agricultural nutrients. These aren't just companies, they're alchemists turning atmospheric lead into economic gold. The numbers are both humbling and hopeful. Current global carbon emissions hover around 36 billion tons annually, and while that won't solve everything overnight, it's like giving the planet an immune system upgrade. Projections suggest that by 2050, we could potentially remove 40 to 100 million tons of carbon annually, a planetary reset button that sounds more like science fiction than reality. Visionaries are already dreaming bigger. Imagine networks of capture facilities strategically placed in desert regions, powered by renewable energy, turning barren landscapes into carbon-negative zones. They're integrating cutting-edge technologies like AI-optimized capture systems and exploring biological enhancements involving engineered bacteria and algae. The breakthrough moments will arrive when we can reduce capture costs below $100 per ton, develop 100% renewable-powered systems, and consistently create valuable products from captured carbon. It's not just technological innovation, it's a fundamental reimagining of our relationship with carbon. As one researcher poetically put it, we're creating planetary HEPA filters, massive air purifiers cleaning up our global home. It's a touch of environmental poetry, a dash of engineering brilliance, and a whole lot of hope, all wrapped up in the audacious idea that we can actually heal our atmosphere, one captured carbon molecule at a time. Picture a planetary rescue mission led by an eclectic group of innovators from Switzerland, Canada, the United States, and beyond. These aren't just companies, they're carbon-hunting pioneers transforming our atmospheric crisis into an opportunity. Take Climeworks, the Swiss carbon capture mavens, whose Orca facility in Iceland looks like a sci-fi movie set of giant air conditioners, sucking CO2 from a lunar landscape. Meanwhile, in Canada, Carbon Engineering, founded by Harvard scientist David Keith and backed by Bill Gates, has developed technology that can capture a ton of carbon for $100 to $250, with a pilot plant already operational in British Columbia. Occidental Petroleum's surprising pivot comes through 1.5, an ambitious project targeting 1 million tons of CO2 removal annually by 2024 in Texas. They're collaborating with Carbon Engineering, proving that even traditional oil companies can become climate change solution providers. Global Thermostat brings a unique twist with their modular capture design that can integrate with industrial facilities, potentially achieving negative cost carbon removal. In Iceland, Carbfix is turning captured CO2 into stone through pioneering mineral carbonation technology, literally petrifying our carbon problem. North American innovators like Carbon Cure Technologies are converting captured carbon into construction materials, while Prometheus Fuels in the USA is transforming CO2 into carbon-neutral transportation fuels. Across the Atlantic, Mission Zero Technologies in the UK is developing an electrochemical capture approach with lower energy requirements. Government-backed research powerhouses like the Pacific Northwest National Laboratory and the National Renewable Energy Laboratory are pushing technological boundaries, developing novel capture materials and next-generation technologies. Investment is pouring in, with Stripe Climate committed to purchasing carbon removal credits, and Breakthrough Energy Ventures, led by Bill Gates, supporting multiple startups in this emerging sector. The narrative isn't just about technology, it's about a global coalition reimagining carbon, from an environmental threat to a potential resource. By 2030, this market could be worth $10 to $15 billion, with the potential to remove 40 to 100 million tons of CO2 annually by 2050. These companies represent more than corporate entities, they're planetary problem solvers weaving together technology, economics, and environmental stewardship in an audacious bid to rewrite our climate story. Droplet, green hydrogen, the clean energy rockstar, a hydrogen-powered odyssey. The clean energy revolution. Imagine a world where our trucks exhale nothing but water vapor, where ships glide across oceans powered by the sun and wind, and where industrial plants hum with that electricity of pure potential. Welcome to the green hydrogen revolution, a technological symphony conducted by an unlikely ensemble of global innovators. Leading this planetary performance is Nel Hydrogen from Norway, the world's largest electrolyzer manufacturer, transforming water into fuel with the precision of a master alchemist. Their American counterparts at Plug Power are racing to develop fuel cell technologies that could make diesel trucks look like relics from a polluted past. In the United Kingdom, Hydrogen One Capital is playing matchmaker, connecting ambitious hydrogen startups with the investors who can turn their dreams into reality. Meanwhile, across the North Sea, German companies like Siemens Energy are engineering grid-scale hydrogen production solutions that could make entire countries energy independent. The national strategies are equally audacious. Germany has committed a staggering €9 billion to become a global hydrogen technology leader. Australia is transforming its vast, sun-drenched landscapes into hydrogen production powerhouses, eyeing Asian markets with the strategic vision of a global energy trader. Japan isn't just participating, they're aiming to become a full-fledged hydrogen society, reimagining their entire industrial ecosystem. Technological wizards are emerging from every corner of the globe. Bloom Energy in the United States is developing solid oxide electrolyzers that could revolutionize industrial energy production. ITM Power in the UK is crafting modular hydrogen solutions that look more like precision instruments than energy equipment. In the developing world, giants are also awakening. Reliance Industries in India is investing heavily in green hydrogen, targeting industrial decarbonization with the determination of a tech titan. In Saudi Arabia, Aquapower is leveraging abundant solar resources to produce hydrogen, part of a bold strategy to diversify beyond oil. The research front is equally exciting. Stanford University is developing breakthrough electrolysis membranes, while Germany's Fraunhofer Institute is engineering next-generation electrolyzer technologies that seem to dance on the edge of scientific possibility. Investment heavyweights like BlackRock and Bill Gates' Breakthrough Energy Ventures are pouring billions into this hydrogen future, treating these technologies not as risky bets, but as inevitable transformations. The automotive world is joining the revolution too. Toyota's Mirai and Hyundai's hydrogen trucks are not just vehicles, they're rolling ambassadors of a clean energy future. Imagine city buses that leave nothing but water in their wake, turning every commute into an environmental statement. Emerging startups like Modern Meadow, Zephyr, and H2 Pro are the wild cards, the potential disruptors who might just crack the code of ultra-efficient hydrogen production. By 2045, projections suggest hydrogen could power up to 20% of global energy needs. This isn't just a technological shift, it's a reimagining of our relationship with energy. From the windswept coasts of Norway to the sun-baked deserts of Saudi Arabia, from the research labs of Stanford to the manufacturing floors of Siemens, a global team is writing a new chapter of human innovation, The hydrogen revolution isn't coming. It's already here, one electrolyzed molecule at a time. Battery solid-state batteries. The energy storage revolution. Solid-state batteries, these next-generation batteries, promise to dramatically improve electric vehicle range and charging speed while reducing environmental impact. They use solid electrolytes instead of liquid ones, offering higher energy density, faster charging, improved safety, and potentially longer lifespans compared to current lithium-ion batteries. In the not-so-distant future, where charging an electric car feels as quick as grabbing a latte, enter Maria, a sprightly EV enthusiast of 2040. Maria's car runs on a solid-state battery, and she revels in her newfound ability to zip 1,000 miles on a single charge after a mere 5-minute pit stop. Current lithium-ion batteries? Maria dismisses them as the clunky VHS tapes of energy storage. Her solid-state powerhouse is compact, unfazed by extreme temperatures, and safe enough to make even the most anxious insurance agent sleep soundly. But Maria's story isn't just a testament to the wonders of these high-tech batteries, it's the result of a global race involving corporate titans, nerdy research powerhouses, and sneaky tech giants, all vying to claim the throne in the kingdom of solid-state supremacy. The corporate gladiators in one corner, there's QuantumScape, a Silicon Valley startup that's been hoarding $1.5 billion in funding like a dragon protecting its treasure. Backed by Volkswagen, they boast technology that can hit 80% charge in just 15 minutes. Across the ring stands Solid Power, rubbing shoulders with Ford and BMW, armed with their all-solid-state cells crafted in Colorado. Meanwhile, Toyota is the battle-hardened warrior promising a breakthrough by 2025, aiming to roll out EVs with a jaw-dropping 500-mile range. The brainiacs with beakers. If you think scientists don't know how to party, meet the folks at Argonne National Laboratory and MIT. Argonne's researchers are cooking up futuristic solid-state solutions with the side of government funding. Not to be outdone, MIT's lab coats are tinkering with electrolyte materials that might just turn your smartphone into an energy powerhouse. The material alchemists. Then there are the material specialists, like Panasonic and Samsung SDI, who've been in the battery game so long they might as well have invented the concept of electricity. They're busy crafting prototypes that could light up your life, or at least your living room. Tech titans and mysterious mavericks. Even the tech giants are jumping in. Rumor has it Apple is secretly conjuring up solid-state batteries to power iPhones that charge faster than you can say. Low battery anxiety. Meanwhile, Microsoft is dreaming big, envisioning data centers that thrive on futuristic energy storage. The visionaries from the East over in China, CATL and BYD, are cooking up their own battery magic, targeting not just cars but grid storage too. Think of them as the silent players quietly rewriting the rules of energy distribution. The competitive circus. The stakes are high. Solid-state batteries promise a utopia of faster charging, longer lifespans, and fewer fiery mishaps. The entire market is brimming with unique approaches, from ultra-fast charging tech by Israel's Thought to Factorial Energy's wizardry with energy density. Tomorrow's battery wonderland. By 2050, these batteries might power not just our cars but entire energy grids. Imagine renewable energy stored so efficiently that blackouts are a thing of the past. Cities will hum with electrified precision, and Maria will still be cruising, reminiscing about the days when charging in 5 minutes seemed like a big deal. Solid-state batteries are no longer just the next big thing, they're the stuff of dreams. And in this rapidly evolving energy race, everyone's a contender, each with a game-changing idea up their sleeve. Who will win? Only time and perhaps Maria will tell. Robot, Sustainable AI, the brainy, green computing wizard. Sustainable artificial intelligence researchers are developing AI algorithms and computing systems designed to be more energy efficient. This includes creating more compact neural networks, developing specialized low-power chips, and designing AI systems that can run on renewable energy sources. Imagine an AI system so energy efficient that it runs on a solar panel smaller than a laptop. In research labs around the world, computer scientists are developing neural networks that consume a fraction of the energy of current systems, potentially reducing computing's massive carbon footprint. Future scenario: by 2045, AI could be a critical tool in solving complex environmental challenges, from optimizing renewable energy grids to modeling climate change solutions with unprecedented accuracy. These technologies aren't just scientific achievements, they're humanity's love letter to the planet. We're essentially telling Earth, sorry for the mess. Here's a mop, a filter, and a really cool technology to clean things up. The future isn't just sustainable, it's delightfully weird, wonderfully innovative, and packed with more potential than a startup's pitch deck. We're not just fighting climate change, we're reimagining how we live, work, and interact with our planet. So, who's ready to turn this tech fantasy into reality? Raze's solar-powered, hydrogen-fueled, AI-optimized glass, Africa, rocket. Don't forget to hit that subscribe button. It's the easiest way to stay charged up and support our channel.